Hi everyone, my name is Krystal and I'm a staff front-end developer on the Insights team at Shopify. Today, I would like to walk you through how we extracted the code that we had originally built for React in web in React Native so that we could make our development process for mobile faster. But before we dive into the implementation details and have a look at the code, I would like to first talk about this library that we built. The library is called Polaris Viz, and I guess that the best way to understand what Polaris Viz is to talk about what data visualization looked like at Shopify before we had Polaris Viz. So before, each team was responsible for making their own decisions in terms of what data visualization should look like, and either implement their own solutions or choose a library that is already out there. And even though there are really good libraries already built, because each team was responsible for building their own solutions, we had a lot of inconsistencies. So let's have a look at these two charts that used to exist in the admin. One of them has vertical grid lines and the other one doesn't. They also use different line widths, different line styles for the dashed lines that represent comparison periods. One has squares in the legends and the other one lines. And lastly, one has a visible x-axis and the other one doesn't. And because they both used completely different implementations under the hood, one had print support and the other one didn't. One had some basic keyboard navigation for screen reader accessibility implemented, and the other one had the super useful area label line charts of sales over time. I'm not sure that that's like the most useful piece of information that a person using a screen reader can have, as it doesn't actually help me understand how my sales are going or what the data points actually are. Even when you had two charts that were instances of the same component, because the styles of the chart were always like defined through props, and we had to like repeat the same styles over and over again on every instance, we ended up having a lot of visual inconsistencies even when the implementation was the same. So to solve all of those problems, we started creating a collection of chart components that not only had the same visual styles, but also had a special focus on things that were important for us, like accessibility and also motion design for delight. For example, in our charts, a user can highlight one specific data series, and that not only allows us to focus more on that specific piece of information, but also helps users with color blindness make the connection between what the shape represents by linking it either to the content in the tooltip or the legend without relying only on color. We also had we also had a lot of focus on how to represent the markup of our components. So for example, our line charts, the SVGs use area rows to make them be interpreted by a screen reader as if it was a table, meaning that you can actually explore the data points through rows and columns. Even though it's an SVG, a screen reader will be able to actually dive into the data and have a look at the data points, etc., etc. We also had built-in support for themes. We want the library to be open source soon, so of course we want the library to be flexible enough so that other brands can use it. And even inside of Shopify, we have other Shopify brands like Shop, Handshake, and Oberlo that do use different visual identities, and we want to have support for that. So in January 2020, Shopify announced that React Native was the future. And since then, we have been focusing on building our mobile apps with React Native. For our team, this meant a really, really, really nice opportunity to get the stuff that we had learned while we were building Polaris Viz for web and actually see how we could, level up the way that we created data visualization experiences for mobile. So, of course, the first thing that we thought was, okay, so we have Polaris Viz, we can create another library, call it Polaris Viz Native, and just build the components to React Native. This was a lot of work, though. At that point, we had been working in Polaris Viz for a couple of years to get it where it was. And starting a new library from scratch, we wouldn't be able to reuse all of the things that we had built. So, what if we explored how we could extract things from the original implementation of Polaris Viz into a third library, Polaris Viz Core? And then in Polaris Viz Core, we would have all of the reusable bits and pieces of code that would be shared between the original Polaris Viz for web, and also Polaris Viz native. Before we actually talk about what we managed to share, we have to talk about the similarities and differences between React and React Native. So in React, we create the markup of the UI by using HTML, old school HTML. And in React Native, we have to import the UI components from the React Native library and use them to create the UI. So you have views instead of divs and text instead of p, for example. Because we're still in React land, we can access all of the common React functionalities like use states or any other hooks, really. And in these examples, you can see that on the React side, original React for web side, we have on-click calling a set counts that manages the state. And the button is just a regular button. But on React Native, we import the button component from React Native and then call it on press. The same way that we did on click, we call it on press, but use state is still the same. Because native apps won't render in a browser, we don't have access to any of the window dot something methods. So we do have a use prefers reduced motion hook that we use all the time to basically define for accessibility purposes if a chart should use animations or not. And in web, we basically call window.matchMedia to check if the user prefers reduced motion or not. We can't do that on React Native, and the alternative is to import the accessibility info module from React Native and call the isReducedMotionEnabled method inside of it to have the same result. Lastly, React Native doesn't actually support SVGs out of the box. So while in browsers you can just write SVGs the same way that you write regular HTML, in React Native you do have to use a library to handle that. So in this example, we are importing SVG, circle, and rect as components from the React Native SVG library. And then you have access to pretty much the same API that you have with old school SVG, let's say. Okay, so let's talk a little bit about the quick wins. These are all things that we basically managed to cut and paste from the original Polaris Viz into Polaris Viz Core so that we could reuse in native later on. The first thing is everything that is just JavaScript. So we had this big constants file where we saved values that were shared across multiple files or multiple components. So these are things like the default values for spacings, colors, configuration for animations, border radius for bars, etc., etc. All of those things we can just extract to core, and then it's nice because we keep the consistency between original Polaris Viz and the new Polaris Viz native. We also had a bunch of utility functions, so things that helped us create these components, like converting an array of solid colors into a linear gradient, the function that actually converts the harsh edges of a line chart into a smooth curve, things that help us work with the data itself. So by, for example, extracting or filtering out the falsy values from a data set. We briefly talked about themes, and the way that the theme implementation works, it was actually pretty easy to extract because, once again, just like cuts and paste from the original Polaris Viz into core for reuse. So out of the box, the library comes with two themes: the default one, which is the dark mode, and the light theme. And the way that this works is that all charts accepts a theme prop, and if you don't pass anything, it's just going to use the default dark, or you can pass in the name of the theme that you want to use. So in this example, it's using light, which is one of the themes that comes out of the box. A theme is basically a big configuration object that has all of the information, not only about colors, but also, for example, about if the lines should use those the smooth curves, or if they use actually like harsh edges, if the bars should use round edges or not, if like what the spacing between the bars should look like, or if the ticks should be visible on the axes or not. Like all of those things that are related to visual styles are defined in the theme. So the library exports a Polaris Viz provider that you can wrap your application with to overwrite the default theme. This is important for the situations where folks want to use some other visual identity, which is not the default one. For example, for other brands apart from the Shopify brand. So in this example, you can see that by specifying that the background color of a chart container in the default theme should be blue, all of the charts inside of my app are going to have the blue background. We don't have to pass in any style props to each instance of the components. They are just going to inherit what was defined in the Polaris Viz provider. We can even have multiple themes. So in this example, I'm specifying that I want an angry red theme, which the background color is going to be red, and a happy green theme, which the background color is going to be green. And then on my Sparkline instances inside of the provider, I just pass in the name of the theme that I created: angry red and happy green. It looks horrible, but it works. And because we have this flexibility, we basically pass in any visual identity that we want, and it's going to like automatically apply to all of the charts across the application. The Polaris Viz provider itself is simply a React context provider. It uses a create themes function that basically guarantees that all of the themes, even if you don't pass that huge configuration object, it's always going to have all of the properties that it needs to render a chart. So for example, if you define only the background color, you are not passing me what the grid should look like, but that's not a problem because I'm just going to use the defaults. So another thing that was really easy to cut and paste from the original implementation was all of the hooks. As I mentioned before, like still React's land, we can just reuse all of the hooks. So things like use Y scale, where we pass in the heights of the available heights of the chart, if it should use integers only or not on the ticks inside of the axes, and the data, and it returns to me a Y-scale function where I can pass in a data point and retrieve the position that data point should represent in the chart, and also the ticks based on if they should only use integers or if we can actually represent floats as items in the axes. The same thing for use X scale, and we also had pretty complex actually a use labels hook that determines if a label should be truncated or not, if it should be displayed horizontally, diagonally, or vertically based on the length of the string and the available size of the container of the label. All of that has to be calculated so that we don't have like overlapping text. So we have this use labels hook, and we basically cut and paste from the original Polaris Viz into Polaris Viz Core. Because we can use TypeScript with React Native, all of the global types that we had in the original implementation of Polaris Viz can also be just extracted. So just with the quick wins, and I'm talking about things that didn't have to be modified in any shape or form, we managed to move pretty much everything that existed in the original implementation of Polaris Viz apart from UI components. But before we actually look into how we can share those UI components, let's talk about what we should share. So this is what our line chart looks like. And we could possibly reuse the component for the y-axis, the component for the x-axis. A legend might make sense too. Also, we have the component that represents the grids behind the lines. And each of these curved lines with the little gradients and also the animation when the chart loads, all of that is a component called line series that we map through the data series to display on this chart. And we can probably extract the line series as well, because we want the lines to look the same regardless if it is on web or on native. We should probably not extract the tooltip though, because I'm not super convinced that tooltips make for great user experiences on mobile. Our thumb tends to get in the way when we are trying to read things, in contrast to the experience where we are just like hovering on stuff and the cursor is really tiny so you can actually read it, and it's a good experience for desktop. We need to think of a better alternative for that. So, how to share UI components? As I mentioned before, the main difference between React and React Native is actually how you create the markup. So, views versus divs, for example. So, how could we share the UI components between the libraries? The first approach that we tried was using a library called React Native Web. And this library is amazing because it basically takes care of everything that you would need to get your React Native components and render them in a browser. So theoretically, we could rewrite the components that we had in Polaris Viz Web with React Native and put it in Polaris Viz Core and use React Native Web to render them in the web version of Polaris Viz. By doing that, we can pretty much move the bits and pieces that form the chart components to Polaris Viz Core, and then leave the actual chart components, like the whole experience of a chart, in a Polaris Viz React, so that we can have the full experience that is platform specific in Polaris Viz React, and the same thing in Polaris Viz Native. So, for example, in Polaris Viz React for web, we would have the interaction with hovers to show the tooltips, and in Polaris Viz Native, we could have something that explored gestures, for example. The problem with this approach is that not only Polaris Viz React Native would need the React Native Web as a dependency, but also the original implementation for web, as it would also be using the native components that live in core. This might not seem much, but if we compare the bundle size of React DOM, you can see that the React Native Web is almost double the size. And remember that we talked about React Native not supporting SVGs out of the box? That means that the web version of Polaris Viz would also need React Native SVG as a dependency. And these things add up. Shopify is a complex system with a lot of dependencies already. And because we have customers everywhere in the world, including places that don't have access to fast internet connection, by adding these extra dependencies, it can make a huge difference into how a merchant can actually log into their account and manage their business. So, how can we share UI components but also keep the bundle size small? Use dependencies only where we actually need them. We already have a Polaris Viz provider, a context provider that we are going to use both in web and native. What if this provider could also determine what the markups should be used depending on where we are? For example, the provider could accept a components prop. And then in web, we are going to pass a list of web components, and in native, we are going to pass a list of native components. So in core, we would have a platform agnostic provider that gets re-exported both in web and native, but with the right components for each platform. For example, in Polaris Viz Native, we can import the original platform agnostic provider from core and re-exports it by passing basically passing an object that maps the SVG tags to the tags imported from the React Native SVG library. On web, on the other hand, we do a similar thing by importing the platform agnostic Polaris Viz provider from core, but then we just pass in a list of components that wrap the default functionalities of SVGs for browsers. So if we had some share component in web, let's say a bar, for example, instead of directly writing SVG markup in the return parts of the code, we would actually get that markup from the context. So in this example, I'm extracting the SVG tag and the rect tag from the Polaris Viz context, and then actually using those tags to build the UI. In web, SVG and rect are default browser-like SVG tags, and in native, they come from the React Native SVG library. So now that we talked about the overall strategy of what this could look like, let's have a closer look into what it looks like in a real chart. We have a component called Spark Bar Chart. Just for context, spark charts are really useful for representing a trend. So it's not meant to be used for you to deeply explore a data set, but for you to have like a quick idea of how something is doing. Like in the Shopify admin, we use these kinds of spark charts in context bars. So this page, for example, the main goal is not for you to explore the data; it's for you to work on your orders, but it's useful to see, for example, if the orders are trending down or if the fulfilled orders are trending up. Um, so the Spark bar chart file in Polaris Viz native looks something like this. We first import the Spark bar chart props from Polaris Viz core because we are sharing the types between both libraries. And we also import use Y scale, use X scale, and the bar component from Polaris Viz core. We then use the things that we imported, like the hooks that we imported, to get all of the functions that are necessary to actually draw the bars based on the data set in the screen. And then we map through the data set to actually create one bar for each data point. And because bar, which comes from core, is not using the path tag directly, it's getting it from the context. I'm in Polaris Viz native, so it's going to fetch the path from the React Native SVG library. We then import a chart container, which also lives in Polaris Viz native. And the reason for that is because the chart container calculates how big the size of the chart should be depending on the available screen space. So basically, it's going to inherit the size of the component that contains the chart. And to do that, in React Native, we have the views instead of the divs. And we also have a prop called onLayout, which gets triggered every time that the size of the component changes. We then pass in a function, handle onLayout, which basically handles when that event is triggered. We then save the width and the height that comes from the event in a state and use React clone element to pass that to all of the children of chart container. In web, we use Resize Observer, which is basically a browser-based API, to do a similar thing. Every time that div changes, we get the new width and height, and also use React.clone element to pass the width and height to all of the children. By using React's clone element in this chart here, we can actually have access to the width and heights that was calculated by the chart container, even though we are not explicitly passing it as props. So after a lot of exploring, failing, and trying again, we got a solution that works, and it makes it easy for web developers to help us expand the library for mobile with React Native. With these building blocks in place, we can reimagine what a good data visualization experience looks like in mobile. So take a line chart, for example. It looks really well for large screens, as we can hover on things. If we hover on one specific line, we can highlight that one specific line. It's a good interaction, but the way that it currently works is that we have that thumb problem where you're covering the data while you're using the chart. And because we were just like shrinking down something that was originally built for a large desktop screen, we are not taking advantage of the features that could make this a good experience. Really annoying to have the thumb on top of the thing that I'm trying to read. So probably a better experience would be to have something like pinch gestures to zoom into a specific period of data, or zoom out and see like more data points on the screen. We could use, for example, two fingers to scroll to see the data that is outside of the screen, or one finger to explore the data that is already visible. And we could have a fixed tooltip on the top of the screen that is not going to be hidden below my finger. Maybe we could even have something like voice commands, like show me the data between June 8th and June 10th, and then the chart automatically filters it out to show that specific range of time. So yeah, that's the future of Polaris Viz. As I mentioned before, Polaris Viz is going to be open source soon. So if you want to have access to beta test the library and help us understand what the Grace data visualization library looks like, both for web or for native, feel free to reach out to us on polaris-viz-feedback@shopify.com, or reach out to me directly on Twitter. My username is Krystal Campioni. And that's it for today. I really hope you enjoy the session.